Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today in this lecture series of the subject solid waste management, today I will discuss you about the radioactive waste. So in this lecture series, in this class, I will discuss about the radioactive waste and what is radioactive waste and from where this waste is coming and what to do, what is the treatment methods for this radioactive waste. Okay. So let's start. This radioactive waste is also called as nuclear waste. So the nuclear waste is the radioactive waste. The radioactive waste which is coming from the nuclear activity, nuclear research projects is called as radioactive waste, and it is mainly produced by the nuclear reactor or sometimes left over from the research projects, medical uses, and the manufacture of nuclear weapons. So this nuclear radioactive waste is coming from nuclear power plant or sometimes from nuclear research projects, medical uses, and manufacturer of nuclear weapons. So the waste that is coming from these things is called as nuclear waste. So radioactive waste is potentially dangerous because it is emitting the ionizing radiation that is going to damage to human health, like it produces mutation and birth defect and causes cancers also. So here one term is there that is called as mutation. Mutation will be there. So this radiation, this will be having this radioactive waste is a very dangerous waste because it is producing some ionizing radiation. So this ionizing radiation can enters to your skin also, and it will change the genetic makeup of a person. So if a genetic changes will be required, will become after because of this ionizing radiation, it produces mutation to the genetic makeup of a person, and that is maybe causes in for the birth effects also, and sometimes it is causes cancers also. So this is a very harmful radiation. This ionizing radiation will enter to skin and causes mutation to the genetic makeup, and in this way many harmful diseases and birth defect, and sometimes it will cause cancers also. The degree of that risk depends upon the level, type of radioactivity. Sometimes with some material that is being hazardous in raw forms, and others are there, they are posing little threat in more circumstances. So this degree of risk is basically depends upon the levels and some types of radioactivity, because radioactivity types is also important, because in this way we can have idea like how much it is dangerous, or at what level it is more dangerous, or at what level it is less dangerous. So some materials are there which are being hazardous in raw forms, and other are there which are posing little threats in many circumstances. So this is about the risk, the degree of risk, which depends upon the levels and type of radioactivity. Means which type of radioactive material will be there, what is its level of intensity, like it is high or low or moderate, or sometimes it is like a very hazardous in raw form, and it will be posing some little threat in most circumstances. Okay, so come out to the next point. There are type of nuclear waste. So nuclear waste, as I have already discussed, that nuclear waste is depending upon the intensity of the waste, like high waste, high level waste, low level waste, like that only. So very low level waste like VLLW. Very low level waste means they are having low amount of nuclear material. Low amount of nuclear material. So it covers waste with very low concentration of radioactivity. So it's those nuclear waste which are containing very low level of radioactivity is called as very low level waste, and its source is hospitals and industry in sometimes general. So this will cover the waste with very low level concentration of radioactivity, and its main sources is hospital and industry in general, because very low level waste contain little total radioactivity. It will contains very little amount of total radioactivity, It can be disposed of safely with domestic refuse, either directly at landfill site or indirectly after the incineration. So it will contains very little total radioactivity. Total radioactivity element is very less amount it is present, and it can be disposed of safely with domestic refuse, either directly to landfill site or indirectly after the incineration. So this is disposed of very safely to the domestic refuse, either directly it can be disposed to the landfills, or it can be indirectly disposed to the incineration. In incineration, what we'll do, we'll burn out this type of waste. So by burning, it will be totally vanished, and as we already discussed that it is contain very low level nuclear waste, means the amount of radioactivity is very less. Next is the low level waste, like it includes some metals, soil, building rubbles, or organic material which arises principally as lightly contaminated miscellaneous scrap. So, next is the low level waste LLW. It includes some metals, soils, building rubbles, and organic material which will now arises principally as lightly contaminated miscellaneous scrap will be there. Next point is like that the organic material are mainly in the form of paper towel, clothing, and laboratory equipment that has been used in the area where radioactive material are used, such as hospital, research establishment, and industry. So, example of this low level waste is like when some things will be there, some like towel or paper or laboratory equipments that came into contact with this type of waste, with this type of radioactive materials, and they have been used there. So, such as like its example is the hospital, some research establishment, and some industry. So, in this way, we can say that this type of material will contain very low level of radioactive element. The radioactive element is present there, but its concentration is very low. So, for this type of things, what we'll do, we will send it to directly to the refuse center, or it's sent to directly to the landfill sites, or sometimes indirectly after the incineration. So, low level waste will include some metals, soil, building rubbers, organic material which arises principally as lightly contaminated miscellaneous scrap. Next is about the intermediate level waste. So, intermediate level waste is the ILW. This is the waste with radioactive level exceeding the upper boundaries of low level. Okay, but what does not need heating to be taken into account is the design of a storage or disposal facility. So, this one is about intermediate level waste, means some intermediate level of waste, intermediate level of radioactive waste. Radioactive waste is there. So this is the waste with radioactivity level exceeding the upper boundaries of low level waste, but it does not need heating to be taken into account in the design of storage or disposal facility. ILW arises mainly from the reprocessing of spent fuel, from general operation and maintenance of radioactive plant. So it will be coming from the reprocessing of some spent fuel and from general operation and maintenance of radioactive plant. The major component of intermediate low level waste is are the metals, organic material with smaller quantities of cement, graphite, glass, and ceramic. The major components is the intermediate low level waste are some metals, organic material with very smaller quantities of cement, some graphite will be there, and some glass and ceramics. So this is about the description about intermediate level waste. This is the waste with radioactive level exceeding the upper boundaries of low level waste, like the radioactivity level is up to more than the low level waste, but it does not having heating to be taken into account, means it will be not be have exceed to the more limit, or it should be account in the design of a storage or sometimes the disposal facility. ILW will arise mainly from the reprocessing of some spent fuel. It will be coming from the reprocessing of some spent fuel and from general operation and maintenance of radioactive plant. The major component of ILW are metals and organic materials. The main components of this ILW are the metals and organic material with smaller quantities of cement, graphite, glass and some ceramic. Next is the high level waste. So first we have a study about the low level waste. Then next is the HLW. This is high level waste. So high level waste is the heat generating waste which has accumulated since the early 1950s, primarily from the reprocessing of spent nuclear fuel. So this will be coming from spent nuclear fuel. The temperature of HLW may rise significantly. So this factor has to be taken into account in designing storage and disposal facilities. So this temperature of high level waste is rises significantly, and the factor has to be taken into account in like designing storage or disposal facilities. As with ILW means intermediate low waste, LLW, ILW and HLW. So low level waste, intermediate level waste, level waste and high level waste. And the temperature of HLW may sometimes rises significantly. So this factor has to be taken into account is like designing storage or disposal facilities. With ILW, there is currently no final management strategy for HLW. So there is no current management strategy for high level waste. Next, you will see that the how we will do storage of this radioactive waste. So the store waste is only approved in the bags in container. So the storage can be approved only in the bags and containers. Okay. So these bags, boxes and carry boys are available from lab safety supply. The lab safety supply will be there. They will do the supply of some bags, boxes, care boys. Okay, so they are doing the supply of these things. So bag is mainly for the yellow color bag will be there with radiation level. So bag is the color of the bag should be yellow and the radiation level should be there on the bags. Same in case of boxes also, lined with the yellow bags. On the boxes also it should be lined with some yellow bags, and bottle are there which is attached the radiation level. On the bottle, the radiation level should also be attached. Same in case of bag. So same in case of bags or boxes or bottles. So for all three, yellow radiation level will be attached. Is attached. Okay. So and the full level, when the full level with the username, department, isotope activity, date and seal with the liquid tie off. Do not use anything that can be mistaken for ordinary trash container. So anything we cannot use for this radioactive waste. Only this type of specified bags or bag or boxes or bottles we can use, and that too will be having some radiation levels also. Like yellow color will be there with some radiation level, like in line with the yellow bags. So same like in this case, when the full level with the username, department, isotope activity and the date should be filled, and it should be sealed with a liquid tied off also, and it cannot be mistaken for the ordinary trash container. So we cannot use anything that can be mistaken for the ordinary trash container. Okay. Next point is like do not mix the aqueous and organic waste. Sometimes aqueous waste is there, aqueous and organic waste is there. So these two cannot be mixed, because Do not mix liquid and dry waste. That is, do not dispose of such items as pipette tip in a liquid waste. Empty scintillation vials are dry waste only. So, do not mix the liquid and dry waste. That is, do not dispose of such items as sometimes the pipette tip will be there. Pipette tip, this pipette tip is like a liquid waste only. This should be used for liquid waste only. And segregate the dry waste by half-life equal to the less than 120 days from half-life greater than 120 days. So we should segregate the waste by its half-life, and the half-life means up to this time only this can be half of it can be disintegrated. So half-life can be discussed like that. Half-life can be discussed like that. Up to that time half of the nuclear waste is disintegrated, and from half-life to greater than 120 days. Do not mix the scintillation vial that contain different radionuclide. So the scintillation vial should not be mixed, which will contain different type of radionuclides also. Do not use Coke bottle, milk bottle, etc. for liquid waste. So the liquid waste which will be having radioactive waste. Radioactive waste will be there. Radioactive waste will be there. So for this, you cannot bottle bottle cannot use. Bottle cannot use. Okay. So these are 3 to 5 points. That is again one precaution measures for this radioactive waste. So first point is that the aqueous waste and organic waste should not be mixed. Next is that like that do not mix the liquid and dry waste. So the liquid waste and dry waste cannot be mixed, which is like that of do not dispose of such items as the pipette tip in liquid waste and empty scintillation vials are dry waste. Segregate dry waste by half-life equal to or less than 120 days from the half-life greater than the 120 days. Means we should segregate all the dry waste by its half-life, and that should be equal to or less than 120 days from half-life that is greater than the 120 days. Next is like the scintillation vial that contain some radionuclides should not be mixed, and do not use some Coke bottles or milk bottles for liquid waste. Next is some legal method of disposing of radioactive waste. So for this legal methods, it basically depends upon DIS, like decay in storage. Dump to sanitary sewer. Only RSO may ship to disposal site and disposes as if not radioactive. If it will be not radioactive, then you can go for the dispose also. So decay in storage means store waste in the laboratory if the half life is no more than 120 days. So you can store it if the half life is not more than 120 days, is not more than 120 days. DIS is again decay in storage. Like DIS isotope must be held for decay for at least 10 half-life. See, this isotopes must be held for decay of at least 10 half-life. Survey monitoring of material must read close to the background. So the survey or the monitoring of material, the survey monitoring of material, it must come close to the background also. All radioactive labeling must be defaced. So the radioactive labeling must be defaced and documents in log will be there. So these are 5 points that is related with the decay in storage. So dry waste in the laboratory if the half fill is no more than 120 days. DIS isotope must be held for decay for at least 10 half-lives. Survey monitoring of materials must be read close to the background, and all radioactive labeling must be defaced. Documents should be there in log also. Dump in sanitary sewer. Must be water soluble or readily disposed biological materials in water. So when it should be dumped in the sanitary sewer when it must be water soluble. The radioactive waste must be water soluble or radially dispersible biological material in the water. Concentration per month is limited by the regulation. Check with the radiation safety officer. So the concentration of the waste per month is limited by the regulation, and it should be checked with the radiation safety officer, and it may obtain permission from the radiation safety officer prior to the dumping. So before dumping it into the sanitary sewer, it should be take permission from the radiation safety officer. So if they will allow, then only you can do, and you can dump into the sanitary sewer. So for sanitary sewer, it must be water soluble or readily dispersible biological material in the water. So the concentration per month is limited by the regulation. Check with the radiation safety officer, and may obtain permission from the radiation safety officer prior to dumping only. Way to know if the people are dumping. So the next point is like annual limit per facility. So for H3 it should be 5 curie. For H3 isotope 5 curie, up to 5 curie you can dispose. In case of C14 also, like 1 curie, up to 1 curie only it should be disposed, and all other nuclide which will be combined with each other. So in this way 1 curie will be allowed. 1 curie will be allowed. So, curie is the unit in which we will measure the radiation level, and H3, C14 are the radioactive isotopes. So, H3 can be disintegrate up to 5 curies, C14 can be disintegrate up to 1 curies, and some all other radionuclide will be there which can be combinedly disposed of up to 1 curie only. So only the radiation safety officer may ship to the disposal site. So up to disposal site, only the radiation safety officer may dispose, and contact radiation safety officer when you have a full container of dry or liquid waste. So in case of dry or liquid waste, dry waste or liquid waste both can be disposed to the disposal site. Disposal site waste will be stored in the radiation shed until the scheduled pickup. So the radiation safety officer will do all monitoring and will do all checkup that it should be sent to the disposal site, or when it should be shipped, or it should be sent to the disposal site. And then the radiation safety officer will be having full container of dry or liquid waste. Same in the case of the disposal site, waste will be stored in the radiation shed until the scheduled pickup will be there. So this disposal site waste will be stored in the radiation shed until the scheduled pickup will be there. Next point is like it will be disposed as if not radioactive. If it will be not radioactive, then you can do its dispose. Scintillation medium containing more than 0.5 microcurie per ml of H3 or sometimes C14 may be discarded as if it was not radioactive. Okay, then what happens? If the chemical solvent is disposed of properly, the radioactivity will not pose a problem. So the chemical solvent is disposed of properly, the radioactivity will not pose a problem also. A record shall be kept for each such disposal for the life of license. It may be sent to RSO also. Next is the animal tissue which containing no more than 0.5 microcurie per ml of H3 or C14 may be discarded as if it is not radioactive. If animal tissues is disposed of properly, the radioactivity will not a problem. Okay, so it is about the animal tissue, because sometimes animal tissue will also have some radioactive nuclei. So if it will be not more than 0.05 microcurie per ml of H3 or C14. So it can be discarded. It can be discarded as if it is not radioactive. If animal tissue is disposed of properly, the radioactivity will not pose a problem. So if this animal tissue will be disposed of properly, the radioactivity will not pose a problem also. So this is about the, sometimes it will contain some amount of this radioactivity will contain in animal tissue also. So in this case also, if the animal tissue will containing not more than zero point 0.5 microcurie per ml of H3 or C14, it can be discarded. And if it is not radioactive also, if animal tissue is disposed of properly, if it will be disposed of properly, the radioactivity will not pose a problem again. So this is about the radioactivity materials, and in this lecture we have a study about the nuclear waste, radioactive element, and how to treat this radioactive element, and how many types of radioactive element will be there. So as we have a study about LLW, low level radioactive waste, intermediate level radioactive waste, and high level radioactive waste. So if radioactivity amount is low level, means very less amount of radioactive waste is present, then that can be disposed in the incineration or landfill also. If intermediate level of low of radioactive waste will be there, then this can also be with some proper care, it can be disposed to the incinerator plant, or it can be sent to the landfill also. Next, in case of high level molecular radioactive waste will be there, when the radioactive waste amount will be of high level, means more amount of nuclear waste will be there, then it will be dangerous, and for that utmost care and it's a proper handling will be required. So it will be like that, the proper handling or some real care, it should be having it should be sent for the incinerator, or it should be sent to the safety officer also. They will check it, then they will give the method how we can send it for the disposal facility, and what are the method we should adopt for its proper disintegration and disposal. So in this lecture we have studied about the nuclear waste, and if you have any query, if you have any question regarding these lectures, you can mail me, or you can directly write in the comment box. You can give me mail to my mail ID, shikha.pandy@gmail.com. Okay, so thank you for today's lecture.
Like, share, and subscribe. Hit the bell icon for more updates.